this is not. Yeah. Hi everyone. We are still on integrations. The last video we did, we solved a problem on integration, multivariable calculus. So we are still on that multivariable calculus. We have a problem here which I would like us to solve together. The problem reads, find the volume beneath the surface of z equals xy over the region of the xy plane enclosed by the y-axis. Y equals x and y equals 2. So, when you look at the problem, you can figure out that this is integration of a non-rectangular region. The one we did the previous time, it was an integration over a rectangular region. This is not. The problem says it. So in that case, let's start. Solution. First, this is a wording. We're going to interpret it in a mathematical format. It's double integration. So you have your integral sign, you have another one, and you are given this function, z equals xy. So this is xy over the region of the xy plane, that is that d, enclosed by the y-axis, dx dy. Not finished yet. We're going to find our limits. These values they gave us, y equals x, y equals 2. We're going to find the limits to be able to solve this problem. So, let's go a little bit further by sketching this graph they are talking about. Z equals xy over the region of the xy plane enclosed by the y-axis. When we want to plot graphs like this, we do our Cartesian coordinates. You see here, x equals y equals x. If this is our y-axis, this is our x-axis. And we are told y equals x. We all know that this goes through the origin. Oh my God. It's just a straight line that goes through the origin at 45 degrees on the xy axis or xy coordinates. This line here, this is y equals x. Yeah, plot graphing. Y equals x. And what? Let us say this is 1, 2, 0 here, 1, 2. And y equals 2. So this is y equals 2. We have now plotted this graph, and another line here, y equals 2. This line is y equals 2. This is y equals 2. So they say find the volume beneath the surface of z equals xy over the region of the xy plane enclosed by the y-axis, y equals x, y equals 2. So this is the region they ask us to calculate. They want us to find the volume of that enclosed region. This region here. That's the volume we're asked to find. So having this graph, transform this problem into graphical presentation. how do we get the limits now of this function? When you are solving double integrals, one thing you should always bear in mind: when you see the y dx dy, it means the y, this last one, dy, goes with this first one. This and this, they go together. And then this and this, they go together. So when you are looking for the limits of this type of problems, the outer limit must always be constants. They must be numbers, not variables. This one could be numbers, it could be variable, this inner one, but the outer one, the limits, they have to be constant, they have to be numbers. And that is the y. So we come now to look for the limit of y. What are they? What are they? What are the limits of y? And when you are doing these problems, you are moving from left to right as you are moving from bottom to top. So this left to right, bottom to top. So this is your bottom. Your left is your bottom. It's like your bottom. Right is like your top. Right? So when you are looking for the limits now, what is on the left should be on the lower limit, and what is on the right should be on the upper limit. So if that is the case, how do you get our limits of dy? We are working out the limit on the y-axis, dy. We are looking for the limits here. They have to be numbers. So we are working on the y-axis. This is the y-axis. So if we cut a line, if we cut another line through here, yeah, from the y-axis to this graph, to this line, y equals x. We want to get our limits there. Here, x is 0. Above the y-axis, x is 0. So you put 0 here. And what is here? What is there? They said y equals to 2. So it's 2. The value here is 2. Y equals to 2. X is 0 anywhere here. And here is 2. At the bottom is 0. At the top is 2. We are given y equals to 2. So we got the outer limits. Now let's work out the inner limits for this one now. We need the inner limit for this one, the x. The x. So how do we work out the limit of the x? Anywhere here, x is 0. Anywhere along the y-axis, x is 0. As I told you before, we are moving from left to right. So here, x is nothing here, is 0 here. This value here, x is 0 here. I put it 0. And what is y? We are going to the what's the right? Along this line. Any point on this line, y is equals to x. Any point here, y is equal to x. So what is x here? Therefore, x here is equals to y. Y. So you now have your integral 0 to 2, another one, 0 to y, xy, dx, dy. xy dx dy. Yeah? So the problem is solved. The problem is solved. We have interpreted the problem into this way. Now it's easy to solve. Can we integrate this? Yeah? When we are integrating, now I need space. We are integrating. So we start with the inner one, the x. We start with the inner one. This is the x, the y. We start with the dx. So if you are integrating the x, it means, let me spell on this marker. We still have a 0 to 2. Now we are integrating x, the x with respect to x. When the y is a constant, we are only considering x because we are integrating x, the x. So this y is constant. So this y got to be there. It's like a number. It's a constant. It's there. If you integrate x, what do you get? You get 1/2 x squared. This y, we add it. Yeah? So you now have this and your limits 0, y, and you still have dy. So one integral is gone. This one is now gone. We have integrated the x with integrated x. That's what we have done here. Okay? So we still have our limits 0 to 2. So now let's solve this first. You have 1/2 x. Now replace x by y, so you get y cubed. You're now replacing this x squared by y, so you now have y squared. So y squared times y is y cubed. Okay? Then you minus. Now you have 0. You have x 0. So any number, anything here is going to be 0. You're multiplying by 0. Yeah? Because there's a 0 now here. Multiplying x 0 to the power of 2. So everything goes to 0. So this is what you get. 1/3 dy. So that is what is left. We now want to integrate y cubed. Again, this is a constant. Yeah? So now this constant, let's take it out. It's a constant, it's a number. If you integrate this, you get 1/4 y to the 4. And you have 0, 2. So this is what you get. So it means now you're having this 1/4. Again, let's take it out. Gonna be 1/8 y to the 4, 0, 2. So what do you get? 1/8 y to the 4, that is 16, I guess. Y to the 3. This simply means, what this one means, you are saying 2 raised to the power of 4. You put 2 here. The y represents by 2 raised to the power of 4 minus 0 raised to the power of 4. This is what this means, this one here. So you still have your 1/8, 2 raised to the power of 4, 16, 2 to the 3 is 8, 16, minus 0. So this is 16 over 8, so your answer is 2. So the volume is maybe 2 centimeters cube. They don't put units, but it's 2 anyway. They don't give us units. So that is the answer. Thank you for watching.